So let us now get into a discussion of trends with respect to metallic and non-metallic character. So first we have to talk about what we mean by metals and what we mean by non-metals. And I think, touched on that particular topic earlier, but let's talk about it again. So metals tend to have a small number of electrons, usually no more than 3 electrons on its valence shell, right? And as such, they tend to lose these electrons to form positive ions. So for example, aluminum will lose all 3 of its valence electrons to form the aluminum ion. Now, when it comes to the different blocks, right, what you'll find is that all S block elements, with the exception of hydrogen and helium, and all D block elements, which would be the transition metals, and some P block elements are metals, right? I think I skipped over D and F block elements. All D and F block elements are metals, and there are some P block elements that are metals, all right? And if you look at the periodic table, you see that the vast majority of elements in the periodic table are metals anyway. In fact, as far as the non-metals are concerned, they only exist in the P block and the S block of the periodic table. So when it comes to describing what we mean by metallic character, we're talking about things like the obvious properties that we observe, plus some others that we can calculate or quantify. But what you'll find is that the atomic radius and the ionization energy is what basically determine the metallic character. So basically, the larger the atomic radius and the lower the ionization energy, the greater would be the metallic character, right? So as such, we can therefore say that going down a group, any group, the metallic character of the element increases, and going from, well, it says from right to left here, the metallic character will increase as well, all right? So basically, you can make predictions as to which metal is more correct, which element is more metallic than the other by comparing their relative positions in the periodic table. And we're going to see some examples of that shortly. As far as nonmetals are concerned, they tend to have a greater number of electrons in their valence shells, usually 4 or more, and they tend to lose, or I should say gain electrons in order to complete an octet so as to form a negative ion, which are known as anions. And all non-metallic elements, with the exception of hydrogen and helium, are in the P block section of the periodic table. And basically, the non-metallic character is going to be the opposite of metallic character for the elements going from, let's say, left to right. So going left to right of any period, the elements will become more non-metallic, and going from bottom to top, again, the element will be less or more non-metallic, all right? So that's basically, and again, it's related to the size of the atom and the ionization energy, right, of the first ionization energy of the elements. Okay, and then we have a third minority group of elements known as metalloids, right? Metalloids are so-called because they do exhibit some behavior in common with metals and other in common with non-metals, right? And these elements are located, well, firstly, let me just say this. In most periodic tables, you see this line, this dark line, stepwise line right here, right? That basically represents a boundary in the periodic table between metals and non-metals. And what you'll find is that metalloids would be located on either one side or the other of this line. So the metalloids would be elements such as boron, silicon, germanium, arsenic, antimony, tellurium, and astatine, all right? And as stated here, metalloids, they have both properties, both in common with metals and non-metals. So these are the metalloids that you need to be aware of, all right? There are 7 of them. I think I misspoke when I talk about astatine being a metalloid. It's not. So these are the metalloids. There are 7 of them, right? And as I said before, they display metallic and non-metallic character. Okay, so this table here is basically a summary of all the trends that we have discussed so far, all right? There's one more I think we need to cover, and that's electronegativity, but for now, these are the trends that you need to be aware of in terms of the different properties and how they vary as you go across a period, left to right, or down a group, all right? So, and also, for most of them, with the exception of the electron affinity, I would expect you to be able to explain why is it, for example, that the atomic radius increases going down a group or decreases going left to right of any period. You should be able to explain it because we covered that, all right? Okay, so let's look at this example here. And again, in order for us to answer questions like these, we need a copy of the periodic table close by. So let me bring it up. I thought I had it here. Okay, here it is. So this question says, in each set, indicate which is the more metallic element. So the first pair here is barium and calcium. And if you look at barium, barium is in the same group as calcium, but below it, right? So therefore, going down, the metallic character increases. So therefore, barium would be a more metallic element compared to calcium. So let me just put here what the answer is. So the answer here is, okay, where is this thing? Okay, this thing is not working again. Let me try this. Okay, here we go. So the answer is that barium would be more metallic than calcium, all right? And then now for the next one, it's tin and antimony. Sb is antimony, Sn is tin. So we have to go to the periodic table again and look for where tin is, and tin is here, and antimony is to its right. So therefore, the answer is that for B, let me go back to this here. For B, the more metallic element between the two would be tin, right? Because metallic character decreases going from left to right. So in the case of B, tin would be more metallic than antimony. And then the last one, germanium and sulfur. So again, we have to go to the periodic table and we have to look at the relative positions of germanium, which is here, and sulfur, which is here. So based on where sulfur is above germanium and to the right, which tells me that germanium would be the more metallic element. So in the case of C, let me go here, germanium would be more metallic. Germanium would be more metallic than sulfur, all right? So that basically is how we answer this question. All right, I'm going to stop this video here, and then we're just going to get into a discussion of different groups of elements, some general information that we need to cover. All right, until next time.